Hello and welcome everybody. My name is Nadezda. I'm an interaction designer with a background in graphic design, based in Switzerland actually. I create interactive playful experiences and my work is often inspired by science. Today I will show you my experiences and approaches as a designer in creation of interactive playful experiences which use scientific output like pictures that come out from research. For me, science is a great source of inspiration for interactive projects. I'm a curious person. I was always fascinated by nature and science. As a child, I read a lot of books about volcanoes, cosmos, and other natural phenomena, in which I especially liked the pictures. At this time, I would never had the thought that one day I will have to do something with games. For me, the picture of games was my brother with a game console with elephant called Dandy. It's a Chinese clone of Nintendo Entertainment System, which is appeared in early 90s in the Russian market. Growing up in the family of architects, it was more natural for me to do something in the design field than something related to science. So I studied graphic design in Russia, where illustration and photography were one of my favorite tools. Sometimes I made things which invited people to manipulate them. However, they were just static visuals. Years later, I moved to Switzerland to study interaction design because I was curious to explore new dimensions and use them in my work, like in interactivity, and was also curious about sound. This is one of the first projects I made related to this. It was an interactive installation which people could interact through an analog object. Also, I started to experiment with programming. This was a project called Decibel. It's an application based on the idea of the barrel organ. It's a mechanical musical instrument which is activated by a person turning a crank. In this application, the tape passing on the iPhone screen while we can hear a song. Let me show you how it works. Up. The song you heard here is called Decibel. It's the earliest known song sung by computer using speech synthesis. You may also know this song from the film 2001: A Space Odyssey. I also made some experiments with code using processing. For example, this was a series of generated posters based on satellite pictures from the NASA database. And here is some more pictures from this series. I really like satellite pictures, and I can spend hours traveling around the Earth by using Google Maps. And one day I found this impressive picture. It's an enormous hole created by diamond mining. It's the second world's largest man-made hole, the abandoned Mirny diamond mine in eastern Siberia, in Russia. It's beautiful and terrible at the same time, and this picture became an inspiration for a future project. And this time I was a fan of the project Image of the Day, released by NASA. And one day I noticed that this database is freely accessible for everyone to use. Initially, satellite pictures were mainly used for research and military purposes, before they became accessible to a broader public through books and the internet. While most of us use them on Google Maps, they're still very important in many fields of science. Today we have a huge amount of high-resolution pictures available. But nobody has time to look through them. So I wanted to make them more accessible in a different, more contemplative and playful way than just looking through a database. That's actually how I started to work on a project called OKO. It's a game, it's a puzzle game, an hypnotic journey around the planet, which uses these beautiful satellite pictures. The goal is to reconstruct the image by stopping rotating circles cut out from this image. For each level, the animated pieces draw increasingly complex patterns. I will show you how it works. So I worked on this project in a team with a developer and sound designer who helped me to release this game on the app stores for Android and iOS. After working on OKO, I was interested to explore more scientific pictures than just satellite pictures. I knew that there is a lot of different microscopic images and space photography that shows different views of the universe. In my next project, I wanted to use this range of pictures to show new visual perspectives of the world around us. And I started working on the exploration game for mobile devices called MIKMA. This game lets you travel to the micro and to the macro world. It's still work in progress, but I can show you a short video of it. You control the game by using different sensors embedded in mobile devices like accelerometer, microphone, or a camera. For example, you have to point the camera to an area with the right brightness to advance in the game. You never need to touch the screen, so you basically never cover the picture with your hands. An important inspiration for this project is the short documentary Powers of 10, a film dealing with the relative size of things in the universe. Let's watch a part of it.
We begin with a scene 1 meter wide, which we view from just 1 meter away. Now, every 10 seconds, we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds, the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1,000,000 meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system.
There is also the second part of this film, which is more dedicated to a microcosm. So in MIKMA, you can explore all these different scales from the micro to the macro world by yourself, by using your mobile device. You can explore each scale by playing a small interactive scene, and each scene is based on the scientific picture corresponding to the scale. One of the visual sources for MIKMA was, for example, this picture made at CERN. It showed the trajectories of particles in a bubble chamber in one of the experiments made in 60s. CERN, as you may know, is the European Organization for Nuclear Research, which is the world's largest laboratory of particle physics located near Geneva. While working on MIKMA, I had chance to go to CERN for months as an artist in residency and make an artistic research residency there. It's a giant lab with many experiments and huge particle accelerators. All these circles on the picture are accelerators ring, and the largest is a Largest Hadron Collider, which is 27 kilometers long. During 1 month, together with game designer Mario von Rickenbach, who worked with me at MIKMA, I visited different experiments and talked to scientists about their work. At first, all these machines and laboratories seems to be very chaotic and a bit confusing compared to the elegant underlying scientific models of particle physics. The experimentalists, the people, the scientists who work on the experiments have a very practical way of working, but as soon as you talk to them, you quickly notice the almost childish curiosity that motivates them to do the work that they do. After all these visits and discussions, we were overwhelmed and we were asked ourselves how could we use all these fascinating things and make them more accessible. We had one very interesting meeting with a retired physicist, Hans Drevermann, who spent a big part of his life working on visualization of experiments at CERN. This picture shows the corner of his office with poster of one of the experiments he worked on. He showed us his approaches to visualize the experiments. The main purpose of these visualizations were to allow scientists to read the data and to better understand what's happening in their experiments more quickly. That's how his computer looks like. It seems he doesn't like to touch aluminum. This day gives us a new perception, I think, about the scientific world in general, and in particular we had a lot of newer ideas how to refine the concept and mechanics and visuals of our game MIKMA. What I want to say, there's a lot of different ways how designers can work with science. For me, it's very inspiring to use scientific ideas and output in projects. I like to play with them, I like to create experiences out of them. I think that complex scientific ideas, they could be interpreted in a more poetic way to make them more accessible. Sometimes instead of creating new worlds, we could create playful experiences based on the discoveries of our real world. Thanks.